Section 4.3 is isosceles and equilateral triangles. So, first we're going to talk about the parts of an isosceles triangle. The congruent sides are called the legs. So, for example, side AB and BC are legs here because they are marked congruent. Then we also have the base. So the non-congruent side, so the third side that's not the two congruent legs, is called the base. So for example, here the base is AC. And the two angles that make up the base are called base angles, and they are congruent. So the two angles at the base of the triangle are called base angles, and you can see that they're marked congruent here. So that's what the base angle theorem says, is that the two base angles of an isosceles triangle are congruent. So you can see the base angles are opposite or across from the two legs, or you can just think of it as the two angles that make up the base. So you can see these are the two that make up the base. So another thing about base angles is that they don't always have to be on the bottom. Okay, they are on the bottom here, but that doesn't have to be the case. So you can see these base angles are not down here. Base doesn't mean bottom when we're talking about it in math. They could be here on the top, they could be here, or they could be on the bottom, but they don't have to be. So the base angle theorem says if two sides of a triangle are congruent, then the angles opposite or across from them are congruent. So angle B is congruent to angle C. So for example, if these two sides are congruent, these are called the legs, then their base angles are congruent by the base angles theorem. So here's my base. So here's one base angle, and here's the other base angle, which is also 52 degrees because the base angles are congruent. So that's what the measure of angle L is 52 degrees. Now, the converse of the base angles theorem is also true. Remember, converse means that we switch the if and the then of an if-then statement. So if two angles of a triangle are congruent, any two angles, then the sides opposite of them are congruent. Okay, remember opposite just means across from. So if angle C is congruent to angle B, then we know that these two sides are congruent. So for example, if my two base angles here, or just these two angles in general, are congruent, here's my base, then we know that the two sides that are opposite of them, let me redraw that, the two sides opposite of them are congruent. Now congruent means equal, so we can set these two side lengths equal to each other and solve for x. Subtract 3 from both sides and we get 9 equals x. Now you can always plug it in and make sure, if you plug in 9 here, we do get a side length of 12 which matches this side length. So you can always plug it in and make sure that they're actually the same, just to check your work. Here we have two side lengths that are congruent, and so this is my base, and if the two side lengths are congruent, then I know the two base angles are congruent. So if this base angle is 50 degrees, then we also know that this base angle is 50 degrees. So we know y equals 50 degrees. Here we're going to use the converse because we have two angles that are congruent. So there's my base, which means that the two sides opposite of those angles are congruent. So if this side here is 9, then we know that y is also 9. And those would be the legs of my triangle. Again, we're going to use the converse of the base angles theorem. If we have two angles that are congruent, then the sides opposite of them are also congruent. So 16 is congruent to y plus 4, which means that we can set them equal. Subtract 4 from both sides and we get 12 equals y. Remember, you can always plug that in and check. 12 plus 4 does give you 16, so these side lengths match, which means that our x value is correct. So here's 3 U-try problems. I'll go through them. Base angles, there's my base. Base angles are congruent, which means my side lengths are congruent. So I can set them equal, and we get 7 equals x. Here my 2 side lengths are congruent, which means my 2 base angles are congruent. So 5x plus 7 equals 52 degrees. Subtract 7 from both sides and divide 45 by 5, and we get x equals 9. And last is the converse. If my 2 base angles are congruent, then I know the 2 sides opposite of them are congruent. So 7x plus 5 equals 19. Subtract 5 from both sides, and we get 7x equals 14, and 14 divided by 7 is 2. All right, equilateral triangle theorem. If a triangle is equilateral, then it is equiangular. So if all 3 side lengths are the same, it also means that all 3 angle measures are the same. Now, we also have a theorem called the equiangular triangle theorem that says if a triangle is equiangular, so if all the angles are equal, then it is equilateral. So if all the angles are equal, then we also know all the sides are equal. So here we said, okay, the equilateral triangle theorem says if all the sides are equal, then all the angles are equal. And we also have the equiangular theorem that says if the angles are equal, then the sides are equal. Now, in an equiangular triangle, and therefore an equilateral triangle, there's only one measure that these 3 angles can be, and that's 60 degrees. Why? Because if we add together 3 angles that are the same measure, so we'll say x, x, and x, they have to sum to 180. And when you solve this equation, you get x equals 60. So in an equiangular triangle, the 3 angle measures are always going to be 60 degrees. Okay, so here we have an equiangular triangle, which means that it is also equilateral. Okay, so if it's equilateral, it means all my side lengths are equal. So that means that 3x equals 2x plus 10. So I'm going to get my variable terms on one side by subtracting 2x from both sides, and we get x equals 10. Now you can always check. So if x equals 10, plug 10 back in here. 2 times 10 is 20, and 20 plus 10 is 30. And 3 times 10 is 30. So, sure enough, we got 30 and 30, so we got congruent side lengths, which means that our x value is correct.